Hello and welcome to Chapter 2, Section 1. We're going to be talking about inductive reasoning today. So inductive reasoning is being able to make a conclusion based on observations or patterns. So we're just going to fill that in for our notes. So make a conclusion based on observation or pattern. A conjecture is a concluding statement that's reached using inductive reasoning. So concluding statement Okay, so the next part of this is being able to find the next 5 terms of a sequence and then write a conjecture. So you're going to want to be looking for a pattern in those terms right there. So we do know that they're decreasing, and it looks like they're all decreasing by 7. So we're just going to continue to subtract 7 each time. So our conjecture would be subtract 7 from previous term. Okay, then looking at that next one, so we have 2, 5, 11, 23, and we're looking for a pattern, so they're definitely increasing. It looks like they are at least doubling, but then a little more than doubling. So it looks like doubling and then adding 1. So we're going to go ahead and double that term there. So that would be 46 plus 1 is 47. And then we have 47 times 2, which is 94, plus 1 is 95. 95 times 2 is 190, plus 1 is 191. 191 times 2 is 382, plus 1 is 383. 383, not 6. 383 times 2 would be 766, and then plus 1 is 767. So the conjecture would be to double previous term and add 1. Okay, continuing on, so we have 1, 4, 9, 16. So it looks like each of those terms is a perfect square. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. So if we continue the pattern, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. So each term is going to be a perfect square. So you square in. So if it's the first term, then it's 1 squared, second term, 2 squared, and so on. So continuing on the next one, we have some letters. So we've got A, D, G, and J. And we're looking for a pattern. So it looks like we are going in alphabetical order, but we're skipping a couple of letters each time. So we're skipping B and C, and then E and F, and then H and I. So we're going to continue that pattern. So we'd skip KL, so we get M, skip NO, we have P, skip RQ, so we have S, skip TU, so we have V, and then skip XY, so we have Z. So skip 2 letters from the previous term. Okay, so I'm going to let you do number 5 on your own. I'm going to help you out on number 6 because that one's kind of hard to get. So number 6 is actually the digits of pi. So this is one that I wouldn't expect you to know off the top of your head. So it's 3.14159263. That's a pretty challenging one. I would not expect you to figure that one out. Okay, so continuing on to that other side. So this one, we are also going to talk about counterexamples. So a counterexample is an example that proves a statement false. So for example, the sum of any 2 consecutive integers is always odd. So that means like 1 plus 2, 2 plus 1, 2 plus 3, 3 plus 4, 4 plus 5, 5 plus 6. All of those are odd. So I'm going to say true. I can't think of anything where it's not. The product of 2 numbers is always larger than either number. So right off the bat, I know that that has to be false because I could multiply by a fraction, which is kind of cheating because that's like division. Or I could multiply by 0. So if I have 0 times 5, that's 0. So the product 0 is actually less than 5. So that proves that that's wrong. Another example would be to use 1/2. So that would be 2 times 1/2, which is 1. So 1 is less than 2. Okay, the next one, the product of 2 perfect squares is always a perfect square. Okay, so we're going to need to think of perfect squares. So like, for example, 1, 4, 9, and 16. So if I do 1 times 4, that's 4, which is a perfect square. 4 times 9 is 36, which is a perfect square. So it looks like that one is going to work out. So that is a true statement. If the area of a rectangle is 6m squared, then the dimensions must be 2 by 3. So area is length times width. So 2 by 3 is one possibility, but it could also be 1 by 6. Dividing by 2 always produces a number less than the original number. So if it's positive, that's true, but if it's negative, that's actually false. So think about it. If I take -8 divided by 2, that's -4, and -4 is actually larger than -8. Okay, next is vertical angles are never complementary angles. So think back from last chapter, we learned about vertical angles and complementary. So complementary means that they add up to 90. So vertical angles, remember, are angles that are like across from each other, so here and here. So that could be true if each of those were 45. Okay, so I'm gonna let you try those last four on your own and then check your answers on the answer key that's provided on Classroom. All right, so continuing on. All right, so that's actually it for section 1. So we will stop